Hello, welcome statistics students to Mrs. Patron's AP Stat class DL style. So all this week, I'm going to try to have a little mixture between Edpuzzle videos and in-person activities or lesson learning. But we are going to be working with experiments for the rest of this week. So I just want to say, I hope that your day is going super well. And I hope that this lesson that I'm going to have for you guys today also goes well. What you're going to need with you, of course, is your chapter 12 outline. I also would recommend if you had an extra paper that maybe you wrote example 2 right up on, that you also have that nearby. We are going to be doing example number 3 in this video. Now, example number 2 was a completely randomized design. And if we remember what a completely randomized design is, I'm going to go ahead and make a little note of that. That's just when you take everything and you randomize everything into 3 different groups, for example, whatever the number of treatments is. Now, that's kind of like simple random sample, right? Everything has the same equal chance of being put into a treatment group, okay? So we will later this week get into other types of experimental designs. Keep these types of designs in mind because we might be doing something with them, okay? Now let's go ahead and let's look at example number 3. I have a couple notes here on example number 3. So a consumer group wants to test cake pans to see which works the best. So if you've ever baked a cake before, you know it makes a difference, the type of material that the cake pan is, and also the type of oven you use. Everyone's used a bad oven before. It's not fun. What we want to see is what's going to give us the best cake. Which cake can we get to bake evenly? Well, we want to find the best combination. We've got 3 different types: aluminum, glass, and plastic pans. We also have gas and electric ovens. So we want to try to figure out different combinations to see what's the best combo, what will give us the cake that will bake the most evenly. Now, as we know, our experimental units are the same thing as the who. So who are we performing this experiment on? We are doing it on the cake batter. Okay. Factors. Okay. I want to write these down on your own outline as well. So the factors are the different types of variables that we're testing. We're testing the pan type. We're also testing the oven type. So the pan and the ovens are our 2 different variables, which is another word for a factor. Now there's lots of levels. The levels are within each of your factors. What are the different types? So for pan, we've got 3 different types of pan. I put a little P here to represent pan. And for oven, we have 2 different types, gas and electric. Now, the response variable is what we want to see. What are we trying to test when this treatment is imposed to see what happens? We want to see which combo is going to give us the most even baking. That's our response variable. That's the response we're checking for. Now, I messed up last week on our notes. I really do apologize. There was a formula that I wrote up here, number of levels times number of factors. I think what I was trying to say was if you have multiple factors, you want to multiply their levels together. I'm not really sure if that kind of came out weird, I guess you could say. But let me go ahead and readjust this and maybe explain it a little bit. So because we have 3 different levels for our type of pan, we're going to multiply that with the number of levels that we have for the type of oven. So it's going to be 3 times 2. So I could say here number of levels for factor number 1 times the number of levels for factor number 2. Sorry again about that little misprint, but hopefully that makes a lot more sense. If you have more than 1 factor, you want to multiply to see how many combinations total you can get. So you might notice a common mistake here is that people just add up. They'd say, oh yeah, there's 1, 2, 3, 4, 5. So there's going to be 5 treatment groups. No, the number of treatment groups is the number of combinations. 3 times 2 is going to give us 6. Okay. So there are going to be a total of 6 different treatment groups. Now we're gonna have to list all of these out for the AP exam. Right now, we're just doing our background work, okay? We haven't actually got up to the write-up or the map or anything, but all of this is gonna be important for helping us to come up with the right answers. So let's go ahead and list all of these out. So I'm just gonna put a little note here. This was a question on a previous AP exam, so I'm gonna take my time with it. Here is one treatment group. You could have the aluminum type of pan, but you have the gas type of oven. You could have an aluminum pan, but you could also do the electric oven. Okay, so notice what I'm doing here. I'm writing them out, but I'm kind of gonna do all of my different combinations. There's no other combinations I can do with aluminum. So now I'm gonna do glass. I could have gas. Ooh, that's a tongue twister. Try to say that 3 times fast. Gas, glass. Okay, and here we're gonna have our 2 glass ones. Now the last one is plastic. So if I have a plastic pan, I'm gonna try that in the gas oven, but I'm also gonna try it in the electric oven. Okay, now I'm gonna write those out completely. Of course, on an AP exam, I'm also gonna write them out completely when I go to do my write-up right now. Okay, so let's go ahead and talk about the map for this one. Please make sure that you include the map with your write-up. I have space here, so I'm going to go ahead and write it on this paper. So the first thing I need to do is I need to talk about my experimental units. Okay, now I'm just going to write out the vocab word. I'm labeling it for the AP exam person, but I'm also going to go ahead and write what the experimental units are. So the experimental units is my cake batter. Okay. Now, it doesn't say how many I should have. Up here, we had 15 plots of lands. I'm not given that information down here. If it doesn't give you a number, you should always have at least 2 per group. And there's 6 different treatment groups here. So we would want to have at least 12. Okay. Now I'm going to go ahead and assign these to the 6 different treatment groups. So we've got 1, I'm just going to go ahead and write this out, treatment number 1. Okay, what is treatment number 1? Well, that is the aluminum/gas group, and there should be 2 in that group, 2 cakes. So you want to have at least 2 per group. Treatment number 2, aluminum. I'm just looking at my list right here, aluminum and electric. Guess what? Another 2 cakes. Treatment number 3, glass and gas. Treatment number 4, we're going to have our glass and electric. Treatment number 5, we're going to have our plastic and gas. And treatment number 6. Now I'm kind of running out of space here, but I'm going to go ahead and sneak in treatment number 6 down here. On the AP exam, you would have a ton of space to write all this out. We're just a little bit limited here. Plastic, electric. I guess I could have done it on a separate piece of paper. I know. Okay. Now, what we're going to do is all of these things need to be measured and compared. So I'm going to go ahead and up here, I'll put all of these. I'm going to draw a line that connects. It's kind of like matching all of these things. Whew, okay. What do we need to do with all of these things? Well, we want to look at the response variable. So I'm going to write here response variable. The response variable will always be what you put measure and compare before. So I'm going to put measure and compare the even baking. I have over here even baking. Measure and compare the even baking. I could put of my 12 cakes if I really wanted to. So just to point out a couple things here, I know this is maybe not the most pretty design. Hopefully yours will look similar to this. But we are going to have measuring and comparing our response variable. We should have our 12 groups. We should have how many cakes are in each group. We should have how many experimental units there are. Awesome. Last thing we got to do is write this up. I'm going to go ahead and do that over here. Last thing, what? Mrs. Patron, how could you forget? There was one thing that we didn't write on our map diagram that was super important, and I made a little fuss about this last week. Randomization. How do these experimental units get into these groups? They are randomly assigned. So I do need to write the word randomization really big across that. Please, please, please don't lose points on the AP exam for forgetting to write that on your little diagram. Okay, let's go ahead and write this up. Example number 3. So let's see if we can remember the different parts of our experimental design. The first thing that we're going to need to do is we are going to need to talk about what kind of experiment we're doing. Now, at the beginning of this lesson, I did mention that this is another completely randomized lesson because every single cake has the same probability of going into any of the treatment groups. The cake doesn't get to choose what pan, what oven it gets. And honestly, it has the same likelihood of getting any of them. So we're going to say a consumer, I'm just going to go ahead and plagiarize here. A consumer group wants to test different pans. Look what I'm doing. This is plagiarizing from the problem. A consumer group wants to test cake pans to see which works the best. Now they're also testing ovens. For what? For even baking. So this is my context here, okay? So I will design a completely randomized experiment. How am I going to do this? So I have to talk about how I'm going to get my experimental units. Again, all I'm doing right now is I'm following the map that I just created. I'm following this. Experimental units. Let's talk about those experimental units. So to get, let's see, I will buy 12 boxes of cake mix from Spar and prepare them exactly as the recipe demands. Okay, and these cake mix, the cake mix or batter will be my experimental units. So I'm talking about how I'm recruiting my experimental units. I'm going to buy them. Okay, and I said how many I'm getting. Okay, and I also am telling the AP reader that I know that those are the experimental units. I will assign, let's talk about the randomization because that's the next part of our piece. Moving from left to right, we've got randomization into those 6 groups. I will assign numbers 1 through 12. Oops. To each batch of cake batter. And write 1 through 12 on identical slips of paper and place into my magic hat. Now, this is where you could use any of the kinds. If you want to use rand int, if you want to use a random number table, use whatever you want. I'm just going to do magic hat. Shaking between each draw. And I have to talk about, am I going to replace or not replace? Wouldn't make sense to replace. Most of these, experiments, you're not going to really be replacing because you want to get unique experimental units to each treatment group. Okay, so here's, take a deep breath real quick. Shake out your hand if you need to, because this is where we have to go through all the treatment groups, okay? Shaking between each draw and without replacement, the first two numbers will be cake batter assigned to treatment number 1 with aluminum pan and gas oven. So notice here, I didn't abbreviate anything. I wrote it completely out. What are they being assigned? Remember that one of the keys to experimental design and doing a well-designed experiment is that someone should be able to replicate it. If it's not specific enough that it can be repeated, it's not a good experiment. All right, I've already started writing down what I'm going to do for treatment number 2. So the next two drawn will be assigned to treatment number 2 with aluminum pan and electric oven. Okay, now I'm going to do a little cheating thing here on your homework on a test. You get the picture. I've explained enough by this point. You would write all of them out. If there were 6 different treatment groups, the next 2 will go to treatment number 3 with glass and gas, treatment 4, glass and electric, blah, 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 all the way to the last ones. The last remaining 2 pieces of paper will be the 2 cakes assigned to the plastic and electric group. Okay, so on the AP exam, you're going to write down everything. That's what that star means. Now, we do need to talk about, does it make sense to do blinding? Does it make sense to do placebo? No, we're working with cakes here. So not necessary. To blind cakes or use a placebo. We're working with humans. That's really the only time that we are going to have to use those. Now let's talk about controls. I will bake all batter at the same temperature for the same length of time. And the recipes will be identical. Now, I know I already mentioned that earlier, so it's not really so necessary to mention it again. Up here, I said that I was going to bake them all the same as the recipe demanded. We do just need to mention somewhere what our control factors are. All right. Because I've talked about baking them at the same amount of time, normally I would say after 12 minutes, I'm going to take them all out of the oven. That would be a very short time to bake a cake, by the way. But in this case, I'm saying they're all going to be baked the same amount of time. So after that amount of time, I will hire, okay, this is where we can have a little bit of fun. I'm going to hire Gordon Ramsay, an unbiased cake expert, maybe Cake Boss, to measure and compare the even baking. So what am I doing here? What I'm saying is, after I've listed all of my treatment groups here, Measure and compare response variable. Measure and compare the even baking of the cakes as my response variable. And that's it for our completely randomized design experiment. Hope that you enjoyed this video. I hope it's beneficial, and good luck on the homework. Bye-bye.